Good day, Math 30-1s. We continue our discussion of Chapter 4 Trigonometry with trig equations, which essentially takes your 4.2 creation of the unit circle, which takes your 4.3 understanding of angles and ratios and their connection to the unit circle, and builds on top of that with solving equations that involve trig. So we are going to be algebraically solving first and second degree quadratic trig equations in radians and degrees with restricted domains and as general solutions. So if I were to ask you to solve cos of theta is 1/2, this would be a yesterday question where cosine is positive in two places. The small x value is at a 60-degree reference angle, which gives us the coordinate location, the reference angle of 60 degrees. As we rotate in radians, I see radians, I really should be saying pi over 3 as the reference angle. But as we rotate around in one full rotation, 0 to 2 pi, we get to answer the two angles are 60 degrees, pi over 3, and 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. 1 pi over 3 shy of 6 pi over 3. And this would be the answer to a yesterday question. A today question is solving this first degree equation. Now pretend I were to say, what is 2m minus 1 equal to 0? What is m? You would add the 1 to the right side, divide both sides by 2, and say that m is 1/2. Now, I'm not asking you to solve a grade 7 question. I'm asking you to solve for cos of theta. We can add the 1 to the right side, divide both sides by 2, and get when is cos of theta equal to 1/2. This is not the answer to today's question. The answer is getting theta, which we just did a moment ago. When is cos of theta equal to 1/2? When is cos of theta equal to 1/2? In radian mode, you would say again, pi over 3 and 5 pi over 3. So now we're starting to determine our angle, theta, when there's an equation involved. So a little bit of work before we get to a yesterday question. Some questions involve a little bit more combining of like terms. If we had a 5 sine of theta and a 3 sine of theta on different sides of an equation, we might have to combine like terms. I'm going to subtract a 3 sine of theta from both sides, and the 5 sine of theta minus the 3 sine of theta results in a 2 sine of theta. The 2 could subtract to the left to the right side, and we get a -1. And dividing both sides by 2 gives us a -1/2. Again, the answer should be in radians between 0 and 2 pi. So we first ask, where is sine negative? And this is in the bottom two quadrants, 3 and 4. Sine, being the small value, is at 30 degrees, pi over 6. We answer in radians as not 6 pi over 6, but 7 pi over 6 as our first answer. And our second answer is not 12 pi over 6, but 11 pi over 6. Perhaps you count pi over 6's and get 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7 pi over 6, 8, 9, 10, 11 pi over 6. We want to get to the place where this is comfortable. But in one full rotation, these are your two angles. They can get a little bit more complex as we look at maybe cosecant. And so I do have a theta and an x. These should match. So when is 3 cosecant of theta minus 6 a 0? Many of them just start by doing something. Maybe getting your trig statement by itself. So cosecant of theta, maybe we can divide both sides by 3 and get cosecant of theta is 2. Flip this to become a sine of theta equals 1/2, and we have a very similar question as the last one. But this time, sine is a positive on the top with a 30-degree reference angle. Asking for this question in degrees, your answers are 30 degrees and 180 minus 30, or 150. A bit of comfort as we transition into some more complicated examples. So sometimes there is some factoring included. And there is more than one way to factor. So in the next steps, we're going to solve the following equations, give exact answers where possible, and round to the nearest thousandth of a radian or to the nearest degree. And to the nearest thousandth of a radian, we're going to do this to the nearest tenth where applicable. So if it feels comfortable, you can start to factor trig expressions as you see them. If you feel a little uncomfortable, you might feel like you want to say that every time you see a sine of theta, let's just change it to an m. A sine times a sine is like an m times an m, and a sine of theta is an m. If this feels better, you're more than welcome to take out your greatest common factor and make it look like this. If you don't need to do a substitution, you can just start to factor out a sine of theta and see sine of theta times sine of theta minus 1, and you have a very similar statement. Eventually you're going to have to take this and rewrite this. So this is where we're at. Sine of theta times sine of theta minus 1 is 0. When we're solving quadratic equations, we call this the zero product property, where a product of two factors that equals 0 can look and examine those individual factors to make little mini equations that equal 0. When is sine of theta equal to 0? When is sine of theta minus 1 equal to 0? Or when is sine of theta equal to 1? And all of a sudden, there's two mini equations in one. When is the y value 0? That's when we haven't traveled up or down any, and the y value of 0 happens here, and it happens here. When is the y value 1? The y value is 1 at the top. I wrote these in two separate places, but this could be drawn on one coordinate grid. So I could have just drawn this with 1 up there. Where do these happen? Well, as we rotate around, the first one happens at 0 radians, the next one happens at 90 degrees, or pi over 2 radians, and the last arm happens at pi, or 180 degrees, or pi radians. So in one full rotation, 0 to 2 pi, these are the only three places where this arm happens. So if you plug in 0 degrees, 0 radians, pi over 2 radians, and pi radians into this equation, 0 will always come out. So this is taking out a greatest common factor, but there is the scenario where we do have to factor using our lucky or decomposition approach. So you might again change this to say m squared minus 5m plus 4, so that you see m's instead of 10s. And then maybe you do decomposition or lucky, but however you factor, you might take a moment to try this. I would factor this by doing this and saying m minus 4, m minus 1, or you do decomposition and rewrite this as tan of theta minus 4 times tan of theta minus 1, all equals 0. And this gives us when is tan of theta equal to 4, and when is tan of theta equal to 1. For tan of theta being 4, tan is positive CAST in quadrant 1 and 3. Tan is positive 1 in, again, quadrant 1, quadrant 3. These give us different reference angles, though. If you do a second function tan of 4, it will give you 1.3. And you can try this in your calculator, or you can trust that second function tan of 4 gives you 1.3. I know this is a reference angle because 1.5 is your 90 degrees, 3, 4.5, 6 are good approximations of radians. Second function tan of 1 gives you about 0.8. Now, I'm going to answer as a radian as an approximate angle right now, but technically, second function tan of 0.8 was giving me something kind of special. Second function tan of 1 in, say, radian mode gives you 0.78. In degree mode, it would give us 45 degrees. Now 45 degrees could maybe be written instead as pi over 4. So if you were not quite comfortable, you might have been writing 0.8. If you're quite skilled, you would say pi over 4. So as you try to write down our answers to these, the first answer occurs at 0.8. The next answer occurs at 1.3. The next answer happens at pi plus 0.8. Now pi plus 0.8 is 3.9, and a pi plus 1.3 is 4.4. This would be the less skilled way of answering this. The one that would be a little bit more skilled is if you know that the y value divided by the x value only creates a 1 at 45 degrees. You would, for 3.9, say that's 5 pi over 4. And for and for the 0.8, you would say that's 45 degrees or pi over 4. That would be a better scenario. Now, we just continue to examine different scenarios, but again, this was in radians. And so we're asking, when is sine squared of x or theta? The letter really doesn't matter, but when does it equal 1? When you square root both sides, we get, when is sine of theta equal to a positive or negative 1? When you square root and a variable is involved, you do have a positive or negative result. So when is sine positive 1? When is sine negative 1? Down here. Is this radians or degrees? Well, it doesn't say. Does this mean we get to choose? Sort of. It also, though, means that we have to answer not between 0 and 360 or 0 and 2 pi, but we have to list all answers. So we need to answer, if we're doing this in degrees, there is an answer at 90 degrees, but there's another answer at 180, and every 180 after that. How do we say every multiple of 180 is going to give us an answer after 90 degrees? Well, we can say every multiple of 180 by attaching a multiplier, n, traveling left or right, as the integer is positive or negative whole numbers. In radians, you would say it's 90 degrees, and every pi n, or n pi, where n is an integer. So one of these would be an appropriate answer to this question. So all of a sudden, we're dealing with coterminal answers in general form. We're also looking at square rooting and getting 2 answers because of that. Well, let's look at 3 more examples, maybe just 2 more examples to round off the day. And we have a question that you might pause the video and try, but there is some unique scenarios that happen here. So as we factor cos squared minus cos minus 2, you would result in, no, I'm doing this quite quickly, cos of theta minus 2 and cos of theta plus 1. We do get to answer between 0 and 360 degrees, which seems like I'm going back in difficulty, but there is something unique about this question. We ask when cos of theta is 2 and when cos of theta is negative 1. When is cos of theta equal to 2? Well, here's when the x value is 1, negative 1, but when is your x value off the unit circle? Negative 2. Never. If you type second function cos into your calculator of 2, it gives you an error. Remember, the only answers for cos and for sine are between negative 1 and 1. Decimals are okay, but between negative 1 and 1. When is cos negative 1? That is at 180 degrees as your only answer to this question. It does give us a domain between 0 and 360 degrees, so that is our only answer. Let's skip letter B and maybe tackle a question that's a little bit more complicated. When is sine of x plus 30 degrees equal to 1/2? Now this question is unique because I'm giving something more than just a theta. This is saying if you start somewhere and add 30 degrees, when is your y value going to be 1/2? Like, I know my y value is 1/2 here and here. My y value is 1/2. My y value is 1/2, at 30 and 150. But if it's saying we have to start somewhere, add 30 degrees, and then you get here, where were we? Well, we had to have been at 0 and added a 30 degrees to get there. So if x was a 0, we add 30 degrees. Sine of 30 is 1/2. Or if we are at 150 and add a 30, sorry, if we're at 120 and add 30, we get to 150. So this question's very, very hard to visualize. What we might do to approach this a little bit differently is pretend that x plus 30 is something like an m, and I'm just making up a letter. So if I were to say sine of m is 1/2, solve for m. Well, this question would feel very similar, saying, well, I know the answer is at 30 degrees and at 150 degrees for when the y value is 1/2. But remember, m was a placeholder. If I put m back in as what it truly is, an x plus a 30 degrees and an x plus a 30 degrees is 150, and solve for x in each case, we get our 0 degrees and we get our 120 degrees. These are the values for x, which are a bit of a extension to what our angle looks like. This is probably the hardest question that you might examine in this lesson, but a lot of it involves factoring and trying to solve some unique cases. Good luck in your practice with page 211 as we are officially finished chapter 4.